Hello, this is Kevin Wolf, and I'm coming to you from Software Logistics main office, better known as a corner bedroom in our house that I've converted over where I do most of my work. And what we've got here is a little video that I'm going to shoot on NIVEC DOE QC1. What I've done this weekend is actually configured the software and the GPIO board to actually output from the remote device there and actually spin up for the motors. We've also got our Windows 8 slate here, which will give us our telemetry. So let's just jump right into this. I'm going to go ahead and spin up our power here. As you can see, our motors are spinning up here. I'm going to be very careful here as I come over here and actually move my slate a little bit over so I don't chop off one of my fingers. We can see here we have the output from our telemetry, and as I move it up the quadcopter up and down, we can kind of see some movement in our artificial horizon there. Let's take a look at our chart here. This is very interesting. This is something I really didn't expect, but I think I've kind of got it worked out now. What we've got here is on the top line, that's the actual angle of the quadcopter, which is the kind of the output of a complementary filter from the middle line, which is the gyrometer, and the bottom line, which is the accelerometer. You can see we're getting a lot of noise in the accelerometer on the bottom, and I'm not sure if that's actually from vibrations or from electrical. I haven't sorted that out yet, but hopefully we'll get something figured out on that. But what we've done with software is using a complementary filter, combine the output from the accelerometer and the gyrometer to give us something that's somewhat consistent from the angle up there. I'm still not happy with it. It looks like we're bouncing back within about plus or minus a degree or so, but we'll see if we can clean that up a little bit. But if we go ahead and shut down our power, we can see that the noise disappears. Our accelerometer is nice and clean, but as soon as we introduce our power, we can see that it's starting to bounce around all over the place. I'm not going to go ahead and fly this in this position here because we're actually kind of in cramped quarters here, but I'm just kind of testing the software. We have our ST-Link hooked up to the microprocessor, the microcontroller on our flight board there, and just kind of being able to do all the testing and so on. So anyway, let's take a look at one more thing here. I'm going to go ahead and power up our throttle, and there we have the power going to the front, the port motor, starboard motor, and the rear motor. As I'm actually moving up my throttle, you can see that eventually power is going to be applied to the different motors on there. So hope you enjoyed part 2, and look for part 3 coming very soon. Maybe we'll actually get this thing off the ground.